They can't see it now. They're just looking at the board. Okay, so the whole point of this is trying to get you to understand limiting and excess in stoichiometry. 2 points. Number one, the theory. That's what the beads are for. And the second point is how to actually do the math. And we'll get to that at the end. Okay? So I've asked you to do your beads, different colors, 4 different colors, one to each represent each ion. And you have NaCl. You have as many NAs as you do Cls because it's a 1-to-1 ratio according to our bonding unit. That's what an ionic compound is set up as a ratio, right? So Ben, what do you have for your NAs?
26.
26. Oh, and so how many Cl minuses then?
Yeah, they're the same. 26 and 26.
Good. And how many AGs? You're boring me.
Scratch that, I'm sorry. We have 40 of each and then 26 AGs and then AGs.
I'm asking somebody different. I'm bored.
Sorry.
I'm going to ask, go ahead, Pierce. How many Na pluses?
32.
32. And how many Cl minuses?
32.
Good. How many AGs pluses?
31.
31. Okay. And how many NO3s?
31.
Good. So 1-to-1, 1-to-1. So now you're going to make a solution. By making a solution, you're going to dump that with that. Or in other words, mix all your beads all up together. So go ahead and mix your beads up together.
Oh no.
Okay, you're seeing inside. Whoa. Hello. Okay, and when you mix these two solutions together, you should get a precipitate. Right? Try not to worry about your hair too much, then, Nolan. You get a precipitate. Right? Nolan, focus. I know you're distracted by the video. It's so cool. Grab your pipe cleaner. This is where our precipitate is going to form. So what is the precipitate? AgCl. And on mine, that's 1 red and 1 green bead. What's that on yours? Okay, so you're going to do 1 Ag plus, 1 Cl minus, 1 Ag plus, 1 Cl minus, 1 Ag plus, 1 Cl minus, all the way down your pipe cleaner. So here's your precipitate, precipitating out.
Maybe using some red. It's so stressful.
Don't worry about it.
Oh wow, maybe. Yeah, I guess.
Probably should have asked if you minded.
It's fine.
Maybe I should have limited the amount of beads, but anyway, it's going to take you a while. Go home. What's going to be left over in your tray, by the way, once you finish your precipitate? What are those things? Spectator ions. There they are, still in solution. They haven't really done anything. They've just sat in the tray the whole time. So these are our spectators. What did you just say, Nolan?
We're going to run out of wipes before we run out of things.
Huh. Anybody else going to run into that problem?
Yeah.
I want
Oh, this is nice. Very appealing.
Oh, one of the pipe cleaners.
Appealing.
You're going to run out of a pipe cleaner.
Yeah. Seriously. What did you end with?
So as you're forming your AgCl, do you have more Ags or more Cl minuses?
more Cl.
You have more Cls. So are the Cl minuses in excess for you?
Yeah.
Okay. What about you girls? What do you have more of?
Oh my god. What do we have?
Reds.
Reds is AG.
Ag. So is your Ag in excess? Yeah. And you boys? You don't know yet either. You don't know yet, have you? You finished? So you've got too many. All right, 32 and 31 is too big of a number. I would guess, Pierce and Ryan, that you are going to end up with 31 AGCLs. Can you count how many AGCLs you have? There's one, there's another pair, there's another pair, there's another pair. So count your pairs. 1 pair, 2 pairs, 3 pairs, 4 pairs. Count how many pairs you have. Boys, you count how many pairs you have of AGCLs. Is it the same as your smaller number?
Yeah.
So gentlemen, so how much precipitate we form is dictated by the limiting reagent and not what we had in excess. Say that again, make sure that applies to your example. What you have in excess are the extra beads, I just said. So you have this in excess, you have this in excess, that's excess. The limiting is the smaller number. That's the one that got all used up. That's the one that made exactly the number of precipitates that you have. Right? Is that true for everybody? That the number of pairs that you got on your pipe cleaner is equal to the smaller of these two numbers. Now we're talking about beads. I often don't talk about beads, I often talk about circles. And when I say circles, what am I really talking about? Moles. So this is like you've counted 32 moles and 31 moles. And you've made 31 moles of precipitate. And when we do the moles, we do the mole ratio, right? So if I were to ask you, what would you predict the mass of precipitate to be? And I told you, this is how much we had of this one, this is how much we had of this one, I'm going to use my limiting reagent to cross the bridge, not my excess. I stop. Because the excess ends up being spectating. Some of the excess was used, some of the excess went on the pipe, but some of it stayed in your tray. So you're not actually using your excess as your calculation. You're only using what you've used up of your excess and put on the pipe. Does that make sense? So how much we form of something is dictated by our limiting reagent, not the excess. How do you solve the limiting reagent? Well, in this case, it's the smaller number, but it's not always the smaller number. Okay, it's not always the smaller number. So before we get into that example, does everybody understand this example? Your spectator is in your tray, an excess is in your tray, and it was the limiting that you put in that affected the results. Okay, so this second example, you can use your same color beads, although you might need to get rid of some of them. And we're going to use, instead of Na, I'm going to use HCl. Fine, whatever. So the count here can be the same for your H and your Cls. And for the other reactant, I'm going to use MgOH2. Now what does that mean? Oh, I forgot to do different colors. MgOH2. Now, when that dissociates, what does it dissociate into? 2 OH minuses for every 1 Mg2 plus. So this is how I want you to organize your bead tray this time. You're going to take everything off your pipe cleaner. And I want you to have these paired up. I actually want you to have these beside each other. And I want you to have 1 Mg with 2 OHs beside each other. Does that make sense? So you've got little packets of beads. Right, try that. And for the sake of the people watching the video, real quick.
These will just be 1 to 1.
Two ones for everything.
Sodium.
That's not
You might need to get rid of some.
Reds.
That's fine. That's true. That's right, well done. I'm not sure where the pot, oh, it's, the pot's over by here, so you guys can dump your excess, your extra.
Okay, so MG beds. OH is gone. OH is what? Green.
Okay, so here's your HCLs.
Yeah, no, we messed that
Oh, you messed that up?
We did the wrong colors with each
Okay.
one. But yeah.
So this is your MgOH2,
Yeah.
and this is your
This will be the.
HCl. Okay. You guys, do you need help?
HCl. So we're keeping HCl.
Well, dude, we could just make this 24. 24 for each. And then, take out 12. No.
Boys? What are these then? HCLs?
Yeah.
What are your colors?
Making it 2 to 1.
What are your colors?
Okay.
Down that.
I'm gonna place purple. You have to place whites with them.
So this is your HCl.
Yep.
What color is your H class, boys? Make them up. Just like I done. You put charges on it.
Subtle.
So
subtle.
Okay?
Are we missing one purple?
And you're gonna go MG is going to be
Yeah.
your white, and your OH is going to be
Okay.
They look like creepy
MgOH2.
Yeah, we need one more.
Okay, so
One more
MgOH2.
over.
HCl is
Guess we gotta get rid of these reds.
Okay, so go ahead and. And you don't have to have, like, okay, you don't have to have 20 of them, it's all right if you've got, however many you've got is fine.
Wait, do you wanna give me some? Yeah. Okay. So we're putting.
So count how many HCLs you have, and count how many MgOH2s you have. The density just got there.
24.
Okay.
24. Okay.
Count how many MGs you have and how many HCLs you have. MgOH2s and HCLs.
15. So 24 and 15, I think.
How many HCLs have you girls got?
23.
23. And how many MgOHs?
15.
15 MgOH2s. Okay, you boys ready? So for this example now, because in my balanced equation, oh whoops, I forgot to balance the one on the board. And I forgot to write my products. My products are going to be
HOA.
MgCl2 and HOH. And for every one HCl that reacts, I need 2, wait, is that right? No. For every 2 HCl's that react, I need 1 MgOH. Did we get that?
Yep.
So, your numbers right now, you cannot necessarily go with the smaller number that's there. We could before because it was a 1-to-1 ratio, but now it's a 2-to-1 ratio. So this is how this is going to pile out. For every 2 HCl's, so I want you to take 2 molecules of HCl's. Oh dear. There you go. 2 molecules of HCl's. You take 1 MgOH2. You see that? For every 2 HCl's, you take 1 MgOH2. And you put them over there on the product pile. For every 1, you take 2, put them over onto a product side. Do you boys know what I mean?
Do I put this in the
Okay.
can with it?
Do you boys know what I mean?
Yep.
Okay.
Oh, we just, well, it's just like it's all a product.
I think someone's missing a purple.
Yeah, that's what I was thinking. Well, there's a word right there.
It gets a bit messy, I know.
Just a bit messy. So I got white. And then one's left.
Okay, so that ends up being one of these and half of this. So we'll take one of these and half, chop a red in half,
Okay.
and off it goes. So I'll put it halfway in between, so half of that, half of that, okay? But the point is, you girls have excess MgOH2. What did you guys end up with excess of? MgOH2 as well. What did you boys end up excess with over there? Ha, we all ended up with MgOH2 excess. That's a coincidence, that doesn't always happen. But I wanted to show you here. So on the board, when we did our counts, and I used the girls' counts, we would have said this is the smaller number. And last time we went, smaller number, limiting, that decides our products. Only now I'm saying, look, for every one of these, I need 2 of these to react. So if it's a 2-to-1 ratio, HCl to MgOH2 from the balanced reaction, if I have 15 of these, how many HCl's do I need to react? 30. If I'm grabbing all my HCl's, I would need 30 MgOHs to react. Do I have 30? No, in fact I have too low of a number. This is my limiting. If I react all 23 of these, all 23 of my HCl's, how many OH minuses would I need? 23 divided by 2, that's why we have a half. So I would need 11.5. Do I have 11.5? Yep, in fact I have more than 11.5. In fact I have an excess of MgOHs. Do you see that? And if we built our waters on our pipe cleaner, an HOH, HOH, if you built your waters on the pipe cleaner, you would end up with your H's limiting how many waters you make. And your OH minus is being in excess. So it's not as simple as looking at the smallest number. You also have to look at the mole ratio and see if it's a 1-to-1, then it is the smallest number. If it's a 2-to-1, I've got to do some thinking. Sometimes it's still your smallest number. Does that make sense? Okay? So, and then the math part is, I use my limiting to cross the bridge to find out how many OH minuses I've made. In fact, if you tried, or H2Os, pardon me, if you tried to build your H2Os on your pipe cleaner right now, you would use the pile that was just the product pile. The excess would still be the same excess at the end. Did you get it? You want to try it? Build your waters on your pipe cleaner. HOH, HOH. And then we'll practice some math. So as you build your pipe cleaner, HOH, HOH, only use the one in the product pile, and you will see that's all you can build because you run out of H's.
No. Oh, yeah.